For the case 3, we need to determine direction H and SS at point C, and then we have to draw bending moment diagram. For this section, have value of I. For the first step, we need to change support E to roller, so we can analyze our arch. For our case, as we can see here, it's symmetrical. Therefore, we can cut into 3 sections. So here is M1, this is M2. So value for M1, M2 is equivalent. So value in here, in between, and remember, we take our X direction, start from here, point A. So this is X direction. So in between 0 up to this point is M1, and between E to this point is M2. And then don't forget, between A up to this point is for moment 3. So now let's calculate for M1. Since it's symmetrical, just enough to calculate half side. So we know that 50 kilonewton at point B. Our M1, so we take summation M1 equal to 0, positive clockwise. Or before that, don't forget to calculate direction. So calculate direction. So we have 150 kilonewton, and we don't have force on horizontal, so that is 0 for this section. So here is 150 kilonewton and 0. So take summation M1 equal to 0. Therefore, we have negative M1 plus 150 times X equal to 0. Because for this distance, we don't know yet. So up to X cross section at point B. So M1 is 150x. Since it's symmetrical, so M1 equal to M2. Then we take another section for M3. And this is X direction. We know here is 5 meter. And distance for this one is X minus 5. Our reaction 150 and 0. So we need to calculate what is equation or value for M3. So we take summation M3 equal to 0, positive clockwise. So because M3 is, we take as anti-clockwise, so negative M3 plus 150 times by X value minus 50 kilonewton times X minus 5 minus UDL 20 kilonewton X minus 5 times X minus 5 divided by 2 equal to 0. Solve this and then we can get for M3. Refer back our previous notes. We know formula for H is integration moment y dx divide integration y square dx. So we need to find our y. Formula for y, for our h, for hx l minus x divide L square. We know our L is 20 and our H is 5 meter. So 4 times 5 times x minus x divide 20 power of 2. Then we have our y. So that's for our y. So we can get what is y power of 2. X square minus x power of 3 divided by 10 plus x power of 4, 400. That y power of 2 we need here in our equation. And also we need value for my. Since we have m1, m2 and m3, so we need to find what is equation for m1y and what is m3y. So we have our m1 equal to 150x. So we can get equation for m1y is 150x times by y. We know our y, x squared divided 20. So expand that, we have m1y. So we know our m3 from here. So we can get our m3y 200x minus 10 power x squared times by our y. Expand that, then we have the answer for m3y. Then we need to put those equations to find our h. Now let's find what is the value for integration between 0 to 20, because our length is 20, for y square. So please know how to integrate that. So you substitute value of 20. So we have the answer for that, 266.7. Then we need to find value for integration between 0 to our full length for my dx. Because due to the symmetrical, so we just take times by 2, integration between 0 to 5 for our m1y. Then plus m3y, integration between 5 to 15, and our m3y is x power of 4 divided by 2 minus. Alright, integrate that, substitute those value, then we have the answer for my dx. Integration of my dx, 52,447.9. Then we can calculate value for our h. So the answer for h is 196.7 kilonewton. Now we need to determine our HC and VC. We know our vertical reaction 150 kilonewton, and we just calculate our value for H, 196.7 kilonewton. So this is the figure where is our N and S. Our HC and VC. So we need to determine our HC and VC. From this, we know our HC is 196.7 kilonewton, and for our VC is 150 minus 50 kilonewton, then minus the UDL, 20 times 20, so that 40 kilonewton. So our VC is 60 kilonewton. And we know formula for N and our S. We know alpha is dy dx. We have equation for y, so we have to differentiate that to find our alpha. We know the position for alpha here is 7 meter from point A. Then substitute x equal to 7 into this alpha. So when x equal to 7 meter, alpha is, substitute 7, so we get 0.3 radian. So from radian, you have to convert into angles. 180 times 0.3 divide pi. So we have the angle for that, 17.189 degree. Then we can calculate value for N and S. So value for N is 205.6 kilonewton. Then S is negative 0.8 kilonewton. Now we need to draw our bending moment diagram for our arch. So we know at the middle will be the maximum, which is at point C. And also, since we have a point load at B, so we need to find bending moment at point B. By calculating moment at B and also moment at the middle, which is moment at C, this is the bending moment diagram for our arch. To calculate bending moment at B, we take summation. Moment at B equal to 0, positive clockwise. Remember our cross section we cut at point B before. And also we know our y is x minus x squared divide 20. From our case, we know this position is 5 meter. So substitute in that. When x equal to 5, we have y 3.75 meter. Then we know our horizontal and vertical. Then we calculate moment at B. MB plus 150 times by 5 minus 196.7 times 3.75 equal to 0, negative 12.4 kilonewton meter. That means our value for MB is 12.4. The negative means our assumption is other way around. So then we need to calculate at M peak. Peak gonna occur at C because at the middle, because it's symmetry. Please find how to calculate M peak in our handout provided. MC M peak to 16.5 kilonewton meter. And to draw this bending moment diagram, it's the same concept how to draw the bending moment diagram on beam as you learned that in theory of structure. And here's some notes. We know our M3 equal to 200x minus 10x squared. Then we can find what is our dm3 over dx. Differentiate that, 200 minus 20x. When dm3 divided by dx equal to 0, we can get value x equal 10 meter. Alright, this point is the maximum point for maximum bending moment going to occur, which is at the middle. So here is 10 meter. Alright, that's all for case 3. Thank you very much. Assalamualaikum and have a good day.